I had a request from some of my students to do a demonstration video showing how to find the greatest common factor of two numbers. There are a couple ways that you can find the greatest common factor, but the way that I'm going to demonstrate today is my favorite way, and that involves using factor trees. Now, I have two numbers already written down, 72 and 56. If you have a good background of multiplication facts, then when you see numbers like 72, it probably comes to your mind right off the bat that 8 times 9 gives us 72. Now, I would try to rely on my basic multiplication facts in situations like this. I know some people will look at that and see it's an even number and try to divide 72 by 2, which would give them 36, and then they'll try to divide 36 by 2, which would give them 18, then divide 18 by 2 to get 9, and so on. But I think it's better if you can try to keep your factor trees kind of more like bushes and not have these big long trailing um, factor trees where you divide everything by 2. It's just a more sophisticated way of doing it, I think, um, and it works for me. But by all means, if somebody is just learning their multiplication facts and they see that as an even number and want to divide it by 2 and make their factor tree the long way, that will be fine. You will still have the same prime factorization regardless what two factors you may start with. And in my case, 8 and 9, I could have had 36 and 2. I would still wind up with the exact same prime factorization. Now with 8, I know that that's going to be 2 and 4. And because 2 is a prime number, I'm going to go ahead and circle it. That's the convention that we use. We circle our prime numbers. 4, that's going to be 2 and 2. Now, those are both prime numbers, so I'm going to circle them. With 9, that's a perfect square, and I know that 3 times 3 will give me 9. So here's the prime factorization for 72. I have 2 times 2 times 2 times 3 times 3. And I would have gotten that same prime factorization had I said 2 times 36 and worked my way all the way down, but this was a little bit quicker and a shorter route. Now, I can do my prime factorization statement here by writing 2 times 2 times 2 times 3 times 3. But that takes a lot of space, so I'm going to kind of use my knowledge of exponents here. I have 2, 2, 2, that's 3 2's, so my exponent is going to be 3. So I have 2 to the third power. That does not mean 2 times 3 equals 6. That means 2 times itself 3 times. 2 times 2 gives me 4, and then 4 times 2 gives me 8. Now, I'm going to multiply that by 3 times 3. Now, I could write 3 times 3 here, but I'm going to use my exponents. I have 2 of them, 1, 2, so I'm going to use the exponent 2. Now, once again, that does not mean 3 times 2. I have some students who look at exponents and they sometimes forget and they're in a hurry and they'll write 3 times 2. No, that's 3 times itself 2 times. 3 times 2 is 9. Now with 56, once again, you could divide that by 2 and work it all the way out, but I'm going to try to um, use my knowledge of multiplication facts, and I'm going to think that 7 times 8 comes to mind every time I see 56. And since 7 is a prime number, I'm going to go ahead and circle it. 8, I'm going to factor it down just like I did over here. That's going to be 2 times 4 and 2 times 2. And I could go 2 times 2 times 2 times 7, but once again I'm going to use my exponents. I'm going to say 2 to the third power times 7. Now, when we do a greatest common factor, which is abbreviated GCF, I want to look for those factors that 72 and 56 have in common. Now, I see I have 2 to the third power here, and I have 2 to the third power here. I have a 3 square here, but I don't have a 3 square here. I have a 7 here, but I don't have a 7 here. So the only thing that I have in common is 2 to the third power. Now, I'm going to go ahead and put GCF, and I'm having to use my mouse, so it's hard to control it. And 2 to the third power times, and here's 2 to the third power. I'm just going to write it down one time. They have this in common. This is what they have in common. Now, I could have written GCF equals 2 times 2 times 2. But 2 to the third power, that's already figured out for me. The way it's already figured out for me is here's 2 to the third power, 2 times 2 times 2, and it goes back to 8. So the greatest common factor of 72 and 56 is 8. Thank you for watching.